Okay, so we just computed basically, I guess, so we're in the middle of computing this thing, and we just did like half of it. Basically, we computed this operator acting on our initial state, and now we want to, and we got that it was this, and now we need to do the left side of it, basically. We need to act with this on the final state, the bra on the left. So to work that out, I have these two terms here, but we can notice that the only difference between these two terms is that P and Q are exchanged and R and S are exchanged, and there's a minus sign. So I'll just compute with this term, and then I'll just keep in mind that I'll get another term that looks the same, only with R and S exchanged and Q and P exchanged and with a minus sign. So if I look at this thing acting on the left, on our final state, I just do the same thing I did before. I will expand our psi1 bars like this. And so these are psi1 bars and this is psi dagger, but again, the only difference is these have a gamma naught in them. And since I have two psi bars, those gamma naughts will, gamma naught squared is 1, like the identity. So you can basically just ignore that. And then, of course, instead of U daggers, we have U bars. So if we do that, we get a similar kind of expression that we had before. We have all these B's, we have our contraction still, and we have our exponential term, which is a little more complicated because we have this additional exponential term out here. So I get this. And we have to do the same kind of thing we did before. We have to anti-commute these B daggers to the left to annihilate on the left. And it works out, and I do it pretty much the same way. I get these two things. And yeah, so all that will be left over after I do these integrals and the sums are these contractions and these exponentials. And I just have to make sure I keep track of all of my indices and make the appropriate substitutions. So I will get, because I have these two delta functions, I get two terms, and that's how I get these first two terms. And so that will be our, final expression for this thing, or part of it, because again, we had this term above that was minus, and with P and Q exchanged and R and S exchanged. So I'll have another two terms so this term is just this term with a minus sign and R and X and P and Q exchanged, and similarly this term is just this term with the same replacements. So that's what I get, and now I just need a second because I had a little room, but I didn't have enough room to continue, so I just need to go to a different file. So we have this expression again, these four terms, and which is this, and our scattering amplitude is this thing. So I just we just have to write out this contraction, so it's our usual scalar contraction because we're our Feynman propagator, because we're contracting just the scalar field. So we get this, and I think what I do here, so all that's going to happen basically if we take a look at one of these terms is this exponential is going to multiply through, and so we just need to, it's just like what we did before. We just have to, we're going to get products of delta functions because we have these two integrals over x1 and x2, and they're just going to be, for this term, I guess I worked it out. So I'll get a k x1, so I'll get a q minus p plus k delta function, and then this term I get a p prime minus q minus k when you multiply this exponential through. And okay, so basically if you look at these these four terms, what's going to end up happening is because of the delta function. So if you look in these two terms, this term and this term are the same. and this term are the same. And the only difference is that I have, I guess, well, actually I have x1 exchange with x2. That basically, again, a similar kind of thing happened before. We also got 4 terms, but basically in the end, these 2 terms combine, and the top and bottom terms combine. And so that's why after doing this integral over k, I guess I get these 2 terms. I'm sure I'm not following my own work here, but you can write it out if you want. It's just because of these delta functions, it simplifies things, but I'm not seeing exactly how I got here. But suffice it to say, in the end, I just get these 2 things. Because these 2 terms combine, this 2 will go away. And I'll just end up with this thing at the bottom. Yeah, that's basically all.